Yeah, so hello everyone. So today I'll be talking about more like yesterday news on unit distance conjecture and discovery. So the slide was made a couple of weeks ago, but as all you know, we have released 10 more new proofs on many major open problems in mathematics, but still good to revisit this discovery before. So the unit distance problem is a very simple two-state problem, which asks, does every set of n distinct points in Euclidean two-dimensional space contains at most roughly linear many pairs which are distance 1 apart? So you are imagining putting n points on a plane, and you want to see how many points can have distance roughly 1. And this was proposed by Paul Erdős back in 1946. And it's one of the central questions in discrete geometry. So roughly 2 months ago, actually more than 2 months ago, we announced that an OpenAI model has disproved its conjecture, showing that you actually can have a construction with more than linear number of pairs. So maybe let's say a little bit more about the discovery. So this is achieved by a general reasoning model, which is not trained specifically for math. It's completely general. It's basically a version of ChatGPT. And it's discovered during a side evaluation of the model on some very hard math problems. Because nowadays it's very hard to benchmark a model against math problems since most of benchmark is kind of saturated. So you have to find some hard problem to test the ability. And essentially, that's no harness. You just give a model one prompt, and then just keep thinking about things, and maybe use some tools, and then it arrives at the final answer. And the model has access to the web and the terminal, so it can search for what has been done before. Maybe let's say a little bit on the original construction by Paul Erdős. So the idea is that his original construction is just an m by m grid with a carefully chosen scaling. So you want to put many points on a plane, so you put them in a grid. And you scale that so that many of them has distance 1 apart. And the new construction, it's more complicated. It's a grid over something called rational. It's grid over rational numbers, and you work in a new field L of I, where L is a carefully engineered high-degree real number field. So I'm not going to say much about the detail, but the model basically spells out its intuition in its chain of thought. It says that the degree and height of the algebraic relation can be enormous, but that actually can be a good thing. So model carefully chose this number field so that it actually works, this construction. Okay, so after we got we discovered this solution, we try to see how success probability of the model correlate with the test time compute we spend on the problem. So as you can see, if you put more and more test time compute, you have higher and higher success rate on the problem. So thinking longer definitely makes it more likely to find a correct solution. And in a sense, the model, if you look at COT, the model can introspect and realize it's not making progress in one direction, or it's making some mistake, so it can self-correct and just keep going. So from there, I think it's good to review or introspect on how much progress AI has made. What's the best way to measure maybe AI progress? So Meter has this fantastic graph plot on the x-axis is the years, and the y-axis is for some task, what's the amount of human time you will have to do it. And so the plot is on at this time what's the human time of task the agent can reliably done for us. As you can see, this is basically it's basically doubling every 6 months. Like the length of human work that can be done reliably by AI is kind of doubling every 6 months. Of course, this meter graph is mostly in the area of coding. Yeah. So let's maybe take a look on AI as well. So like almost 2 years ago, the model can solve any problem. Like that's you can think about that as maybe 20 minutes human time for a very good high school students, right? Like Amy it's not very hard. Then let's say a month later, a year later, AI can solve IMO problems. Those problems are way more harder. They are like maybe 90 minutes of human time for top high school students, right? So then like another year has passed, so AI can solve long-standing open problem in discrete geometry. So how many hours does that cost to human? So if we put things on a scale, I would claim that. So in a sense, this is roughly like 6 hours of top human time, but assuming them actually knows all of mathematics. The reason is that this proof is not that deep in the sense that it requires you to understand some ideas from a very distinct field and apply them back to discrete geometry. Like you have to be a very good algebraic number theorist and a very good discrete geometry to do the proof. But if you are very good in both of them, then like it probably only takes you a day or two to really push to the conclusion. The challenge is really to master two distinct areas. So in that sense, AI has this very unique advantage here. They have very broad familiarity across all mathematical fields. And they are also decent in many subfields. Finding this kind of example does not require extreme human time if the human already has the right expertise. But it may if they first must learn the area, because learning the area takes maybe 2 years or so. But if you master all of them, then it's different. So in that sense, AI can shorten the search, can do this math do some type of mathematics better than human just because they know a lot of domain knowledge. As they can think longer and develop better domain knowledge, progress on unit distance reflects this multiplied effect on both trends, like thinking longer and better domain knowledge. And so in a sense, some other mathematical results, they require years of work from the mathematician by pushing deeply on one topic. It's unclear whether we are at that point yet with AI. And after the unit distance, the model we released 5.6 so, which is very, very good at mathematical reasoning. There are so many public results already on them has done by 5.6 so in the past 2 weeks. And also, yesterday we just announced 10 more results in mathematics and theoretical computer science on like different area. Oh, so I think it's already there. So I want to say a little bit on like how do I view the consequence. So I think AI is especially good at connecting distant field of research. Just as how they solve unit distance problem, they connect different fields. So I think mathematicians will be really empowered to use ideas from different fields, which may feel less familiar to them, and because AI can just find the relevant ideas and explain them very well. So indeed, mathematics is never about just problem solving, right? Like the most important human input to the OpenAI solution to unit distance is actually Paul Erdős, who really posed this beautiful question with a simple statement and a very deep solution. So AI found a solution, and the human understood it. And actually, after the release of OpenAI Proof, that at least 5 or 6 follow up on this result by different groups among in the world. So I think AI will make it much easier to iterate on which deep question I was asking, because you can find a common example very easily. And also, finally, the ability to do precise calculation used to be a big part of math. Calculator and then computer really empowered you to do more. You don't have to do calculation yourself. So in a sense, with coding models like Codex and Cloud Code, programmers actually spend more time coding because there's much more they can do once they are empowered. I think similarly, mathematician will also be empowered to use AI to do more math, because now you don't have to do tedious calculation, and you can just maybe focus on high-level ideas or enjoy the process. Okay, that's all. Thanks.